So yeah, thanks Matt for the invite for today to tell you all about Hexagon and Leica Geosystems and where we are in this sort of reality capture sort of world really. But just a little bit of an introduction to Hexagon really. We're sort of a global leader in digital reality solutions, and our sort of strapline, if you like, is empowering an autonomous future. Yeah, so our vision is we want to fully autonomous leverage the industry for sustainable thrive. Our mission is to put data to work to enable autonomous connected ecosystems that boost efficiency, productivity, and quality for our customers. So, what does that mean in terms of reality capture for us realistically? Obviously, reality capture is at the core of the Hexagon Leica Geosystems business. We offer a variety of different technologies that capture the physical world, 3D physical environment, and bring that into a desktop environment. That could be terrestrial scanners that collect 1 million points per second, backpack solutions where you can walk through the environment, a bit like what Charlie mentioned, and kinematic solutions where you can capture data over long distance on moving vehicles, as well as UAVs to capture sort of world from above. We've kind of split this into 3 core main sections within reality capture. We've got the terrestrial laser scanning, the tripod LiDAR mounted systems, which are super accurate and collect a lot of data very quickly, through into what we call mobile mapping, which is MMS, which is the LiDAR sensors on a vehicle moving at speed. Clearly it shows it's on a car, but this could be on a train system or even on a boat. And then through to what we call the autonomous reality capture. So this is the dynamic moving objects to collect, the LiDAR sensors that collect in complex environments, basically. So we've got a whole host of portfolio of sensors, and I think obviously it'll be too short a time to try and kind of explain everything, but just a little bit of a broad overview of what we do. So, market leading terrestrial scanners. The BOK range is the reality capture for everyone. So if you've not got great amount of experience and you just want to capture a space for whatever reason, then we've got handheld and tripod based systems that are very easy to use, through to flying laser scanners and UAVs, through to the more sort of experienced dynamic and mobile mapping solutions, but a whole portfolio of sensors. And just to maybe highlight, maybe our flagship sort of terrestrial scanner in this range is our RTC 360. And the unique thing about this is what we call a visual inertial system. So this tracks the scanner through a real world environment. So you can see on the example there that someone's transitioning through a building, and it's collecting lots of accurate points as it's moving through, and it's mapping this world in the real environment. And the little pixels that it's collecting is it's constantly checking those points for any movement, and is it a sharp edge in a corner, and that's how it's positioning itself in an environment. So you can pop out the other end of the building and it can be positioned, and clearly you need to then strengthen that with overlapping geometry and point clouds in the software. So sensor is a lot of the reality capture sort of aspect to it, but the workflow is more important to us realistically. So we're looking at not only sort of the capture stage, which is using all these different sensors and tablet-based systems and your smartphone to capture all this real-world environment, but then we progress into what we call the preparing stage. So this is where we bring the data into a desktop solution where you can do things like cleaning, automatic cleaning of point clouds, removing of noise, which is cars and people, which I think Chris mentioned, and then maybe the coordination side of things, so the georeferencing, so you're getting a real big picture of what's happened on site, and then we kind of lock that down, and then we move into what we call a managed stage. So point clouds and 360 images, it can be a lot of data, so we need to find ways to easily share and manage that data. So that could be a file format which is highly condensed and reduced, which contains kind of everything that we're capturing, including metadata, through to what we call a Cyclone Enterprise, which is an online collaboration tool. So that the kind of the central source of truth really, where we push all this data onto a server or onto a cloud-based solution, and then we can share that, you know, instantly with kind of key stakeholders. So we, you know, that's a really important part of this whole process, is to efficiently manage and collaborate on this data. And then we're into the and that's the generic workflow as we classify it. But then we move into the more the application specific, which is the delivering and the creation of something from that spatial data. Clearly, point clouds and 360 images are very usable data in their own right, very measurable data, but you know, sometimes we need to extract or fit something to that cloud, and we can do that in various ways. So Hexagon have a CAD solution called BricsCAD, and we can you know, we can create 3D models, floor plans, elevations, sections, you know, all that sort of standard construction type survey deliverables. But then we can look at a more sort of advanced deliverable into some software called what we call Cyclone 3DR. And then we do plugins that sit inside other manufacturers' software. So how do we handle our data in other solutions? You know, something like SolidWorks, for example, or in an Autodesk environment. So yeah, so depending on what sensor you use, it should be the exactly same workflow through preparing, manage, and delivering that data. So when you're looking at the actual extraction, you know, you could probably speak hours about this sort of subject, and you know, we're always problem solving within survey and looking at the different deliverables, and just a few examples on the screen in terms of construction. So looking at construction verification, you know, has it been built, has it not been built, where has it been built, you know, that real-time checking of the data. Clash detection, you know, clashing, anti-clashing is an important part of that construction process. And then we could look at the actual deviation analysis report. So, you know, how far has it been built out of tolerance from a 3D model, and it could be, you know, from smaller objects up to, you know, the example on the screen is huge breaches and building structures. So very rapid way of detecting, you know, how far out of tolerance it is, through to sort of floor flatness, you know, verticality analysis. You know, it's limitless and endless basically. And you know, there's a solution and a software out there to almost detect everything you need. Obviously more about the sort of problem solving deliverables. Like I said, BricsCAD is our sort of CAD package. So from the creation of 3D models in a BIM world through to mechanical and electrical engineering, you know, as simple as the surveying deliverables, which is floor plans, elevations and sections, which is what people kind of want to use it for. But there's a collaboration tool for the construction industry. So again, it's all about sharing and collaborating on this data. We have an online platform at Hexagon called HXDR, or Hexagon Digital Realities, and this is a cloud-based collaboration platform it can be on a very grand scale, from huge Hexagon content which is captured by our city mapper, so huge amounts of data on cities for all sorts of variable deliverables, but you can put your reality capture content in there, your CAD models, your OBJ models, and I think what Chris alluded to, it's all about sort of sharing and visual aspect to this data. So, you know, creating tours, and then people can really see what's out there without actually kind of visiting that site. So we've got tools that can handle all that. In terms of reality capture, you know, a question we get asked realistically is, you know, what are the opportunities? But the opportunities are endless, from the very basic common applications, you know, terrestrial scanner capturing the data in a real world environment, to the more unusual applications of, you know, a subsurface sewer system on a crawler system. So we have what we call a BLK ARC, which is the autonomous side. So this is a sensor that sits onto a robotic carrier and collecting that data as it's moving through that environment in real world. So yeah, so from the common to the unusual, the applications and opportunities that are endless. And then just a final slide on sort of BIM realistically. You know, BIM's all about the people, the process and the technology, and it's rapidly growing as importance in construction sort of BIM projects. So the merging and the mixing of the data, the 3D spatial data, which is kind of the point cloud, the 360 images, the design models, you know, all that has to be sort of brought together in one cohesive BIM project. So yeah, that was very short and sweet from myself, but I'll hand back across.
Thank you. Thanks, Phil.